So in today's video, we're going to delve into the equations of tangents and normals to implicit curves. And so we're just going to go back to the implicit curve that we've been using this entire time, which is the unit circle. We have the equation x squared plus y squared equals to 1. And, in previous videos, we derived, through implicit differentiation that the derivative is given by the expression negative x over y. And for the sake of the normal line, we're going to actually just immediately determine that negative 1 over dy by dx is just going to be y over x. Essentially, we just take the negative reciprocal of dy by dx over here, and we're going to use that, of course, as the slope of our normal line. And so what we're asked to do is we're asked to find the equation of the tangent and the normal at this given point. So 1/2, comma, square root of 3 over 2. So we just chose some arbitrary x value and some arbitrary y value that fall on our implicit curve, and we're going to try to find the equations of the tangent and the normal. And so let's actually go ahead and do that. So we know that the tangent line is going to be of the form y equals dy by dx evaluated at our point, right? So we're going to evaluate it at this given point. Let me call this point A. So it's going to be dy by dx evaluated at A, and then plus some y-intercept b. And so what is the derivative evaluated at our point A? Well, dy by dx is negative x over y, and we have our coordinates over here. So dy by dx is going to be equal to negative 1/2 over the square root of 3 over 2, which is going to be equal to negative 1/2 times 2 over the square root of 3. And, these 2's will cancel out, so we'll be left with negative square root of 3 over 3 if we want to, rationalize the denominator. So that right over there is going to be our slope. I forgot to include an x over here. So it's going to be y equals negative square root of 3 over 3x plus b. And then we can go ahead and input this point we're given to solve for b. So we'll get the square root of 3 over 2 equals to negative square root of 3 over 3 times 1/2 plus b. We can go ahead and simplify this. Over here we can rewrite this as negative square root of 3 over 6 plus b, and we can express the square root of 3 over 2, and we can express that as the 3 times the square root of 3 over 6 so that we have a common denominator, and then we'll end up with b equals to, 4 square root of 3 over 6, right, which is just going to be 2 square root of 3 over 3. And then that right over there would be the equation of our normal line, or of our tangent line, actually. So that's our y-intercept. And then we can go ahead and do the same exact process in order to derive the equation of our normal line. So this right over here is our tangent line. And now we're going to find the equation of the normal line. And so all we have to do is essentially just take the negative reciprocal of our derivative evaluated at this point. And so in this case, we're just going to take essentially negative 1 over this term right over here. So we'll get negative 1 over negative square root of 3 over 3, which is just going to be equal to 3 over the square root of 3, which is just the square root of 3. That right over there is the slope of our normal line. So our normal line is going to be of the form y equals square root of 3x plus b. And then again, we just have to go ahead and input this point over here. So we'll get 1/2 equals to the square root of 3 times, what was our point again? Or actually, wait, no, I think I made a mistake here, didn't I? Yeah, we get the square root of 3 over 2 equals the square root of 3 times 1/2 plus b. And then if we were to solve for b, we would get b equals 0. So our y-intercept is 0, and our normal line is going to have an equation of y equals the square root of 3 times x. And so that right over there is how you would derive the equations of normal lines and tangent lines to implicit curve.